The next speaker is Georgiana of Ecosteer, and he will present us an open source tool for managing decentralized consent management. So thank you, and the floor is yours.
Yeah. So yes, good morning everyone. I'm Georgiana, lead software engineer at Ecosteer. Today I will present you DOOF, data ownership orchestration framework developed within Open Call 2 of Next Generation Internet Initiative funded by the European Union. DOOF is a decentralized open source framework made of different components. It decentralizes data visibility, consent management, and puts it back into the hands of the rightful data owners. It also facilitates the deployment of privacy-enhancing technologies. At Ecosteer, we specialize in data governance solutions, and our privacy-enhancing technologies, DVCO, Data Visibility Control Overlay, and RELE, implement data ownership over both data streams and data sets. DOOF addresses current gap between legislation and data sharing ecosystems, where currently data visibility is mostly controlled by platform owners, and this reduces trust in European data sharing initiatives. The legislation, the GDPR and the upcoming Data Act aim to shift control back to the hands of data owners by focusing on privacy, consent management, and the Data Act on data access and sharing. So, as mentioned, most data exchange solutions today use centralized models where control of data transmission and consent management is placed in the hands of a single entity, a data intermediary. This has high costs and huge legal liabilities. DOOF course functionalities are designed instead to comply with GDPR and Data Act privacy laws. And the main actors are data owners or data subjects and data recipients who process the data. Data owners must be able to granularly grant and revoke data visibility consent, and data recipients must be able to subscribe and unsubscribe from data products and specify purposes of usage, which is how they intend to use the data. And these must be immutable and have explicit consent from the data owners. So DOOF implements a framework that decouples consent management from data sharing layer, and it is made of the components that are shown here in this slide, and they allow to achieve a high horizontal scalability in an event-driven context. I will now go into more detail about each of these components, starting from the smart contract. So the smart contract is at the core of DOOF backend. And it implements decentralization by putting into direct contact data owners and data recipients. It actually models a data sharing initiative, a data exchange initiative populated by these two actors, data owners and data recipients, and by data products and subscriptions. The status of the subscriptions allow to verify at any given point in time and by anyone if consent over her data was given or revoked by the data owner. The smart contract is written in Solidity and is deployed also on Alastria blockchain network. So the services offered by the smart contract can be consumed through client APIs that are available in Python and JavaScript. These APIs, together with the worker, allow to implement applications and integrate these applications with the smart contract. The APIs also leverage on JSON standard for a higher degree of interoperability. DOOF Gateway is an HTTP server. It can be used together with third-party HTTP proxies and authentication services so that it can honor an established security model. It receives requests from the clients, and once authenticated and validated, the gateway forwards these requests to an MQP broker that implements a task queue. The worker is an application and orchestration engine that facilitates the development of verticals that are in compliance with GDPR and Data Act. And multiple instances of the worker unbundle requests from a task queue according to a competing consumer's pattern to have a high horizontal scalability. The worker processes tasks based on the logic that is organized into pipelines. The pipelines are composed of single-purpose pluggable processors that are tailored for specific domain applications. In fact, these processors are execution units or stages. In particular, we have implemented open source processors that are capturing the business logic necessary to grant and revoke data visibility. The pipelines can be formed based on a configuration file, like the one seen here on the right-hand side, and this facilitates the reuse and the implementation of new processors and of different logic. So the worker execution logic is based on 5 different phases. Input validation ensures the syntactic correctness of the input event and that it contains the required properties for it to be processed. Pipeline selection instead retrieves the pipeline to be executed against the input. Pipeline execution executes the processors that populate the main section of the pipeline, while finally pipeline executes all the necessary logic at the end of the main pipeline. The division of the pipeline into main and finally section is inspired from the try-catch finally paradigm, and this facilitates error and exception management in accordance to two-phase commit XA specifications. The last step of the worker is the notification step, and this has the responsibility of notifying clients of the results produced by the pipeline they triggered. So now we see more details about the implementation of the pipeline into the main section. The processors that populate the main section of the pipeline have access to resources that are managed by the worker. These are, for example, database and blockchain providers, but also any third-party extensions that are developed for the given use case. Processors in the main pipeline use the pipeline stack to pass data to the next processors in the pipeline, and this facilitates the reuse of the same processors for different use cases and purposes. Processors that populate the finally section of the pipeline do not have access to the transactional systems that are managed by the worker. They process instead any data that was passed to them by the previous processors and finish any operation that was initiated by the other processors. So going to the notification, the worker notifies clients of the results that they produced thanks to an acyclic communication path paradigm. Typically, an output provider is used, such as an MQTT broker. The acyclic communication path paradigm facilitates integration with systems that expose non-deterministic latencies, such as blockchains. So by using all these components and the APIs, we built an air quality data exchange that demonstrates the capabilities of this platform. And we have integrated our DVCO PET with air quality IoT devices called QBs that are produced by our partner Nexus TLC. And we offered participants to this project to the possibility to monitor the real-time data and control third-party access to it and exchange it for services. So with the pilot, we really verified the scalability and adaptability of DOOF, and as key benefits, it has, in fact, also the integration with available pets via the smart contract, and this provides compliance with GDPR and Data Act. a key benefit is also decentralization by enabling direct connections between data owners and data recipients. Another benefit is flexibility, as DOOF can be tailored for specific domains, and scalability for handling increasing user demand. So in conclusion, DOOF advances the current state of the art in consent management, decentralized consent management, and it could become a universal data governance tool that empowers users and helps businesses exploit new European Union regulations. So thank you very much. If you have any questions, I'm here.
Thank you. We have still 4 minutes time for question. Is there anybody who wants to post a question? 1 second. 1 second, the microphone is coming.
Yeah, very quick. There are other domains that you are considering, some other use cases for applying your technologies?
Yes, so in this project we considered a smart city kind of like scenario, but it can be applied in energy sector, for example, mobility sector. We are starting a project as well in mobility, so this is something that we are working on, and it can be applied actually in any domain where there is data sharing that involves users who own their data and other users who want access to this data in order to regulate consent management.
I think tourism and the cultural heritage could be a very interesting application domain.
Mm-hmm. And that is for sharing which kind of data, like if
Cultural heritage is about content about cultural assets, so connected with the museum talk we had some minutes ago. And tourism are data owners like properties owners and it's plenty of use cases.
Yes, that's actually something interesting. Yeah, that's also a point. Anyway, this really can be tailored for specific user domain. The framework is extensible and different kind of data can be handled. So there's room for applicability in these sectors as well. Yeah.
Thank you.
Thank you.
Anyone else? We have.
Thank you. What is the main reason why you chose blockchain? Because you need complete immutability and traceability of the data, or did I not understand?
Yes. So one key point is that data does not go through blockchain. So all the data is not stored on the blockchain, but the blockchain is used for implementing the decentralization and the direct contact between data owners and data recipients. So really every player in this ecosystem has also an account, will have an account and will be member of this initiative. And thanks to the status of the smart contract and the operations that are done on the smart contract, you can verify. So it ensures that data owners are the only participants who can alter the status of a subscription, so they can really grant or revoke it. And this can be verified, and then any privacy-enhancing technology can check this as well in order to really implement the data sharing process and in compliance with the decisions of the data owner.